Digestion and Organic Chemistry by Aisha Al-Mohammadi and Dauphin Ramirza.
When you ingest food, it is in your mouth, and the food molecules are still intact, although saliva can start to break down starch. It travels down the esophagus, into the stomach, where protein is broken down. The food continues to travel into the small intestines, where carbohydrates and fat are broken down into their basic subunits and absorbed by the villi into the bloodstream to be carried to the rest of the body by circulation.
Enzymes break down molecules. Complex carbohydrates like starch are broken down when enzymes cut the bonds holding the glucose molecules together by hydrolysis. When energy is needed, glycogen is broken down in the same way by adding H2O and cutting the bonds. One example is amylase. Amylase is an enzyme that breaks down starch in the small intestine and also in the mouth. Protease, or pepsin, is an enzyme that breaks down protein in the stomach.
So we've mentioned dehydration, synthesis, and hydrolysis, but what is it? Some molecules can be joined together to make long chains. A common example of this is glucose, which can be bonded together to make starch and glycogen through dehydration synthesis. In dehydration synthesis, a hydrogen is taken from one glucose and a OH bond from another. Together they form H2O, and this is dehydration. With the gaps left over, the glucose fit together in chains. To undo this and break them back apart, H2O is added back and splits the glucose molecules during hydrolysis.
So now that we know how carbohydrates are broken down, where do they go afterwards? Well, carbohydrates are broken down into glucose to be reassembled as glycogen in the liver and muscles. Glycogen is broken down back into glucose when blood sugar levels are low. Carbs are broken down for immediate energy, and the brain needs a constant supply of glucose. Carbohydrates contain carbon, hydrogen, and oxygen atoms, which is a ratio of 1 to 2 to 1.
Protein is made up of nitrogen, carbon, oxygen, and hydrogen. When protein is digested, it is broken down into its basic subunits, amino acids. These are reassembled to make various proteins for different tasks in your body. Some of these include making up enzymes. Amino acids are also used to make keratin, which waterproofs skin, hair, and nails, and actin and myosin, which makes up muscles.
Lipids are made up of carbon, hydrogen, and oxygen, but mostly carbon and hydrogen. After lipids are broken down into glycerol and fatty acids, they are reassembled into fat for energy storage, cushioning of joints, and heat insulation throughout the body. Lipids also make up the cell membranes.
In the small intestines, there are finger-like projections called villi. These increase surface area for absorption of vitamins and minerals. Villi are also lined with microvilli, which further increase the surface area to help the small intestines better carry out its main function of absorption of minerals.
Storage in the body is mainly composed of fat for later energy use. When food is used for growth, it is broken down into its basic building blocks so that the body can use the subunits to restore and make more essential compounds.
When carbohydrates are broken down into glucose, this is used as energy through cellular respiration. C6H12O6, glucose, is broken down with heat in the body to yield chemical energy and the byproducts CO2 plus H2O, which is breathed out.
Different indicators are used to show that organic molecules are in certain foods. Iodine can be used to test for starch, and it turns black from brown-red, and in the presence of starch. Benedict solution is a blue liquid that when heated and in the presence of sugar turns orange/red. Biurette's solution is initially blue but turns purple in the presence of proteins. Lipids will leave translucent spots on paper.
In our lab, we tested lettuce for organic molecules with the indicators we just showed. It only tested positive and very slightly for Benedict solution, and this makes sense because lettuce is mostly made up of water and cellulose and a little bit of sugar.